Hello everyone. In this video, let's discuss how to write a program to find peak element. A peak element is an element that is strictly greater than its neighbors. Given a zero indexed integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums of -1 is equal to nums of n equal to minus infinity. In other words, an element is always considered to be strictly greater than a neighbor that is outside the array. You must write an algorithm that runs in big O of log n time complexity. So here they have given an example. The size of an array is 4. The elements of array are 1, 2, 3, 1. And the output is 2. Here 3 is considered to be the peak element and a function should return the index value 2. The reason why we are considering 3 as peak element in this is because next to this element we have a smaller element, which means this element is greater than the next element. So we can say 3 is a peak element and the index value of 3 is 2. So we have got the output is 2. When I go for the next example, here 2 is considered as a peak element, 2 is greater than the next element, fine. And one more element we can consider as a peak element, which is 6, because 6 is greater than the next element. So here we have two peak elements, you can return any of the index values. That is why they have given the explanation. Your function can return either index number 1, where peak element is 2. So here 2 is considered as a peak element and the index value is 1, or index number 5 where the peak element is 6. So 6 can be considered as a peak element and the index value of 6 is 5. So any one integer value can be returned from the function. Now let's discuss the logic in detail. Here they have given an array of size 7. So we have to solve this question with the time complexity of log n. So to solve this in log n, we have to use binary search. So I'll take a variable int low is equal to 0, high equal to nums dot length -1 and mid equal to 0. So here this is considered to be my low value. And this is my high. Now we have to find the mid value. So for that we have to go inside the while loop. So let's take a while loop here. I have to give the condition as low less than high. If low is less than high, I can go inside and I can find the mid value. The condition which I have set is low less than high. If low is less than high, I have to find my mid value. Int mid equal to low plus high divided by 2. So what is my mid value? 0 plus 6, 6, 6 divided by 2, 3. 3 is considered to be my mid value. After finding the mid value, I have to compare the element which is present on the mid value and the next index value. So if nums of mid is less than nums of mid plus 1. According to peak element, the mid value should be greater than the next element. So here what I am doing is I am checking a condition. The element which is present on the index value mid is less than mid plus 1. 3 less than 5. Condition is true. If the condition is true, this element is not the peak element. So I'll change the low value to mid plus 1. So here if the condition is true, I'll change the low value as mid plus 1. So here what happened? Low from here, it will move to mid plus 1. Low will be moved to this particular index value. Okay. In case if the condition is false, what I have to do is, I have to move my high value as mid. Wherever mid is pointing, that value has to be assigned to high. That's all. Continue the iteration. Now when you go for the next iteration, low value is 4, high value is 6. So 4 less than 6? Yes, 4 is less than 6. If the condition is true, I have to find my mid value. 4 plus 6, 10. 10 divided by 2, 5. So my mid value is 5. Okay. So now check the value. Nums of mid, that is 6. 6 less than the next element. 6 less than 4? No, 6 is not less than 4. So here condition becomes false. If the condition is false, mid value has to be assigned in high. So high is pointing to mid value. Go for the next iteration. Low less than high, low is 4, high is 5. Low less than 5, yes, condition is true. So I'll go inside, I'll find my mid value. Mid value equal to 4 plus 5, 9, 9 divided by 2, 4. So mid value will be 4 now. Okay. After that, check the condition. Nums of mid less than nums of mid plus 1. Nums of mid is 5. 5 less than 6? Yes. 5 is less than 6. If 5 is less than 6, what I have to do? Low value has to be updated as mid plus 1. So low value will be updated as mid value is 4, 4 plus 1, 5. Yes, done. Go for the next iteration. Check the value low less than high. Low is 6, high is also 6. 6 less than 6, condition becomes false. I will come out of the loop. After coming out of the loop, I have to return the high value. High value is 5. So here the peak element is 6 and the index value of 6 is 5. I will be returning the value called 5. Now let's try to implement it as a program. So here I have to take a variable low equal to 0, high equal to nums dot length minus 1, and I have to initialize mid value as while low less than high. Check the condition. If the condition is true, I will go inside the while loop. I will find the mid value first. So mid equal to low plus high divided by 2. After this, I have to check one condition. If nums of mid less than nums of mid plus 1. If the condition is true, I have to update my low value as mid plus 1. If the condition is false, I have to update my high value as mid. Finally, I have to return the high value that gives the peak element's index value. Now let's run the code. Is it passes the test cases? Let's submit the code. Is it passes all the test cases? That's all.